Alright guys, so today we're going to be discussing the 2014 FRQ number 6. So the problem asks for the Taylor series, or the problem says the Taylor series for a function f about x equals 1 is given by this series right here and converges to f of x for absolute value of x minus 1 is less than r, where r is the radius of convergence of the Taylor series. Alright, so for part A, it asks you to find the value of r. You first approach this problem, what you want to do is the ratio test. So just by using the ratio test here, which is simply just this formula right here, okay, you end up getting plus 1 for setting up this ratio here using this equation, and then once you finish this computation here, you end up receiving another point. So right here and here, you end up getting a point here. Now the final point is determining the radius of convergence. So once you finish solving for the limit here, which is simply just you end up taking the original function, so basically the function inside of the series, so the sequence, and you end up setting up function shifted where n is just, you just add 1 to n, so you end up getting this part, and then you end up dividing it by the original function, so here, and then once you end up simplifying all of these, which in this case all you would do is you just recognize that these cancel out and leaves you just with 2n. These cancel out, leaves you with just x minus 1. And then, oh, sorry, this leaves just a 2. And then this cancels out here to leave just a negative 1. And then you're left with this here. And since n is approaching affinity, you have to end up just simplifying this, and you end up getting 2 absolute value of x minus 1. Finally, you end up simplifying the equation here, and since you want it to converge, you have it where it's less than 1, because if the answer, or if the result of the ratio test is less than 1, then the series converges. So what you end up doing is you simplify it, and you end up getting that r is equal to half here. So that's another plus 1. Alright, so for part B, what it's basically asking for is for you to find the first 3 non-zero terms and the general term of the Taylor series for f prime, that's just the derivative of f, about x equals 1. Alright, so starting the problem, let's identify f. So f is just this function we're given. It's also written in the original problem. And so since it's asking for f prime, all you have to do is take the derivative of f prime, or derivative of f, and you're left, and you end up getting that f prime is equivalent to negative 1 to the n plus 1 times 2 to the n times x minus 1, and that's all of this to the n minus 1. So going from here, since it asks you to find the first 3 non-zero terms and the general term of the Taylor series, what you end up doing, the general term of the Taylor series for f prime, keep in mind it's f prime, what you end up having to do is you end up setting n, you end up having 3 different parts, alright, so you have n equals 1, and when you plug that into this new function here, you end up getting 2. When you plug n equals 2 into the equation, you end up getting, or expression, you end up getting negative 4 times x minus 1. And finally, when you have n equals 3, you end up getting a positive 8 times x minus 1, and this is all squared. The x minus 1 is squared. As for the general term of the Taylor series, it's simply just this derivative here, or the derivative of f prime. So usually what you want to do is you want to specify that by writing it out. Now you might be wondering how this is scored, and I'll do that right now. So you end up getting scored on the first 3 non-zero terms. So basically it's all of this part here, Okay. Sorry for the messiness. Anyways, so this all right here is a +2, and then right here again you should denote that this is the general term for f prime for the Taylor series for f prime. So by having the general term, you end up getting a +1. So in total, that's +3. And now on to the next one, part C. Alright, so part C is a lot more complicated than any of the other parts. Now, what you first recognize is that it's asking about a geometric series for f. It's saying that f prime is a geometric series, and it's wanting you to find the function f prime to which the series converges for the absolute value of x minus 1, which is less than 4, or less than r. So all that's really saying is, since it's converging and you know that f prime is a geometric series, you end up taking the formula for for the sum of geometric series. So that's a, which is the first term of the series, over 1 minus r, which is just the ratio. So from part B, we know that a, the first term, is equivalent to 2, and the ratio is, in this case, is -2 times x minus 1. And once you simplify this all out, you end up getting 2 over 2x minus 1 is equivalent to f prime of x. Now, since it wants f, or the antiderivative of f prime of x, what you end up doing is you end up integrating 2 over 2x minus 1, and you end up finding that it's ln of 2x minus 1. Now, once you end up getting this, you have the constant plus c left here. What you end up having to do is, since you know x is equivalent to 1, when you have x equals 1 in this series, it always ends up yielding a 0, so you have that f of 1 equals 0. All right, and plugging 1 into this equation here, you end up getting that ln of 2 minus 1, so ln of 1, plus c equals 0, and that basically is just 0 plus c equals 0, so c equals 0. Finally, what you end up getting is that f of x equals ln of the absolute value of 2x minus 1 for the absolute value of x minus 1, which is less than half, because r is equivalent to half. Alright, so in regards to the scoring, if you end up defining f prime of x as this fraction over here, that's a +1. And then if you end up doing this step all here, you end up getting, so basically this whole step is taking the antiderivative of f prime of x. So if you do all of this, that's another +1. And by getting the answer, which is basically just f of x, that's another +1. Alright, so before we wrap up this video, I just want to go over some quick tips. So the first two are basically about the entire AP test. You always want to solve for whatever you can. In each part, you saw that there are really simple ways to get points. For example, in part A, all you had to do was set up the ratio and use the ratio test, and that alone ends up giving you 1 point for setting up the ratio test and another point for computing the limit of the ratio. On top of that, you want to read everything carefully. In part B, if you don't know that it's asking you about f prime, you end up having to, if you don't realize it's asking about f prime, then you would solve for f and get everything wrong on that problem. As for specifically this test, for this problem for Taylor series, you always want to use the ratio test. Typically, the problems will be asking you for what r equals, like what the value of r is. So by using the ratio test, you'll be set and you'll always get free points because of that. Finally, sometimes you have to relate old/irrelevant topics to the problem. So in part C, it asks you to consider the fact that f prime is a geometric series. Now, in the problem itself, it seems like geometric series are kind of irrelevant. However, once you start solving it, you end up having to use the formula for the sum of a geometric series. And in actuality, this tip, although it applies to part C, it also applies to a lot of the AP tests, which requires you to apply your previous knowledge to the test itself. Alright, well, that's the end of the video. Hope you enjoyed it. Bye!